All of our IT infrastructure, including the internet and all personal computers, use a lot of energy, and that's only increasing in the years to come through more widespread use of the internet across the globe, as well as AI becoming more of a thing. So the problem we're trying to solve is essentially make computers more efficient so that we can have the same sort of throughput that we have currently, but at a much reduced energy cost. The existing state of the art in computing at the moment is the von Neumann architecture, which essentially keeps the computations, so the calculations that are performed by computers, and then the memory and the data storage separate from that. And there's a lot of energy that's used and wasted in transferring the data to do the computations and then to store it. So this is called the von Neumann bottleneck, and it's something we're attempting to overcome by inventing new types of computing that have the memory and the computations happening essentially in the same place. These architectures could end up being more brain-like. The human brain, the calculations and the computations that are happening are in the same place as the storage of memory and information. So one of the things we're looking at is the co-location of the memory and the computations. So one example of this is a matrix vector multiplier chip, which basically does this operation that's very common, but where the calculation is happening essentially in the same place as the memory storage. So this matrix vector multiplier chip could potentially be up to 100 times as fast as existing chips. We are also looking at using optics, so light, instead of normal electronic computations. This can also increase efficiency and then speed up computations. Metamaterials feature in a lot of the work that we do. Quite often we use metamaterials for plasmonic enhancing, which can allow us to shrink down fields and make devices smaller. We also make active metasurfaces that can change the way they respond to light, depending on switching a particular component in the material. This opens up a lot more space for them to be used in lots of different situations where just a single fixed functionality isn't enough. Through this work on computing and using metasurfaces, we hope to be able to increase the efficiency and speed at which computations are done.